In today's session, we are going to discuss about gravitation and solve some MCQs related to the concepts. Okay. First of all, I have divided this chapter into two subtopics, and the subtopics includes. Just a second. Let me choose pretty quickly a pen to write. Okay. So today we'll be discussing gravitation chapter under two topics. One is actually a force. Okay, there actually is gravitational force. Gravitational force. We'll be learning here how the planets attract each other, about what's the force related to universal gravitational constant and those stuffs. Okay, and in second part we'll be learning about gravitational field intensity. Field intensity. In this topic, we'll be learning about accelerations due to gravity, and from these topics the most of the questions in competitive examinations are asked from. Right? So from these topics, the most of the questions are asked in competitive examinations. So let's talk about some concept. Let's learn something about the concept of gravitation. So what exactly is gravitational force? So again. Okay, so let's talk about gravitation. What exactly is gravitational force? Remember, our gravitation was discovered by Newton, and he was like, he had doing some research in the he was doing some research in the work related to gravitation. Then suddenly he was just thinking and wondering, sitting under the apple tree, and then the apple fall down. He just had an idea why does it fall down, why not up, why does it behave so, and he started doing his research. So this is was the little bit history of gravitation, and from then onwards, from now, there's been a lot discovered and published in papers, and now also there's a concept of gravitational waves, which are the ripples in this space, and so science is eventually progressing, and we are far from here. So now let's talk about a very basic concept of gravitational force. So what does this gravitation say? Is that if there are two planets, let's say planets having mass m1 and m2, separated by distance r, let's suppose. Okay, so the force, so the planets m1 and m2 are always, there is one force that exists between these bodies. Let's not say this planet, because this body can be any bodies, not only planet. Okay, so there is one force that exists between planet m1 and m2, and the magnitude of that force is directly proportional to their products, the mass of their products, and also inversely proportional to distance between them, inversely to the square, inversely proportional to the square of the distance between them. So this was a gravitational law is simply about. Okay, and just combining these two equations, we get F is directly proportional to m1 m2 upon r square. So this is what else gravitational force is proportionality relation. Okay, so now from these things we can conclude that there is one inverse square rule. It is a central force. Okay, so this is a fundamental force in nature. There are many forces present in nature. Okay, so first we can talk about electrostatic force, gravitational force. There is strong force, nuclear force. So there are many forces, but the one quantity we can see from this thing is let me change color. From this, it is there is an inverse square rule here. Look at here. This follows inverse square law. This inverse square law. This is called inverse square law. Inverse square rule. So this is called inverse square rule. So this is a point number one, but this is a characteristic of gravitational force. Okay, so now let's remove this proportionality constant, and let's remove this proportionality signs and bring a constant. Okay, so here's the okay, so there's some stuff happened, right? So let's remove this proportionality sign and bring a constant, and the constant was supposed to be g. Okay, so g was not supposed, was found to be g, and m1 m2 upon r square. So this is how we get the formula of force. What does this equation says? Their equation says that in between two planets m1 and m2 there is a force existing, which is directly proportional to product of their mass and inversely proportional to the square of the distance between them. And solving this proportionality and removing the proportional sign and introducing a constant, they're found to be one constant which value, this is g, is universal gravitational constant, which is found to be 6.67 into 10 to the power minus 11 and unit. And talking about the unit, let's solve the unit for g. Okay, so let's solving for the, okay, what is happening. Okay, so let's solve about the g is f r square upon m1 m2, which simply is, what's the unit? Force unit is newton and distance unit is meter square upon kg square. So this comes out to be the unit, so we can say newton meter square upon kg square. So this is a little introduction about gravitational force. We talked about the gravitational force, and you know the features. Let's talk about the features. One feature which already discussed is it follows inverse square rule. Okay, it follows inverse square rule. Let's talk about features of gravitational force. Features of gravitational force. Okay, so let's not say features, because let's say characters. They are same things, but still characteristic sounds good, you know. Characteristics. Okay, so one characteristic is follows inverse square rule, and second, let's talk about second characteristics. So second characteristic says that it is always attractive in nature. Okay, it is always attractive in nature. What do you mean by always attractive? I mean, if these two bodies, let's say this one body is m1 and m body to m2, these two bodies tends to be always attractive, unlike the magnetic force which can be repulsive, unlike electric force which can be repulsive. You know, electrostatic force of attraction can be attractive as well as repulsive. If there is two charges plus q and minus q, there is a field exists from the plus to minus, and this force is always tends to be attractive force, whereas the similar charges there is a repulsive force. So this is what is one feature of characteristics of our gravity. There is also another characteristic, you know, it is also this very much, it is medium independent. What does it mean? It simply means, you know, the gravitational force is just independent of medium. Wherever you go, wherever in this space time, wherever you go, there is no any kind of change in magnitude of the force if some kind of medium is introduced between them. Even if you place some walls over here, okay, so let's say even if you place some sort of barriers, let's say there is a wall over here, there is always an attractive force between these two masses. This is what it is talking about. Are you understanding, right? Okay, so this is what is a medium independent. No, you go to the sea, even if sea there is water, so that medium that acts as medium, but it doesn't care. Our gravitational force doesn't care if there's water or whatever there is, it doesn't even care about it. So it is always medium independent. This is very much important. Okay, so this is one, this gravity, and this is, you know, and let's talk about another characteristic. And the next characteristic, it is a very strong or weak force. What do you think? Is the gravitational force a strong force or a weak force? Many of you might think that it is a strong force. There are many planets over there just having the attraction force, you know, heavenly bodies. It must be it must be, you know, very strong, but it's not that strong. Okay, so it's very weak force, you know, this very weak force, but dominant force. I mean, it's a very weak force, unlike the electrostatic force, which is very powerful force, unlike nuclear force, you know, the force inside the nucleus of atom, that's very powerful force. Okay, so it's very weak force. So gravitational force is very weak compared to our nuclear force or electrostatic force. Its magnitude is so much less. And let's talk about this force. Talking about the force, you know, in every body there is now attractive force. Even if there is a attractive force between every single body, and the magnitude, we found the magnitude of the body. And now what? Now what is remaining on gravitational force? I have just discussed about this magnitude, and okay, let's just talk about it. So let's just conclude gravitational force here. Okay, if there comes any kind of concept, then I will discuss at that time. Okay, so now let's go to another topic, that is gravitational field intensity. This is very important, so what is gravitational field intensity? So gravitational field intensity is just simply says there is a field in this universe. The fields, it talks about the fields. It's actually a what? It's actually a vector quantity. You do know vector quantity? Vector quantity. It is actually a vector quantity. Quantity means it has both magnitude plus direction plus follows the vector addition of triangle. Vector addition rule. Addition rule. So this is what is vector quantity. You have to learn in very detail what are vectors. So it is considered as a vector quantity, and the gravitational field intensity's formula is given as, it is denoted by G. We can denote it just by G. So let's talk about here field. Let's talk about field. Okay, so it is just denoted by G, and its equation is given as what is G m upon r square. Where same thing. M is the mass of a single planet, and r is the radius of that planet. So this is what is, and now what's the force experiment? How did the we call it, so this is earth. Okay, so let's suppose this is earth, and there's this source of field, gravitational field, by this, this is a planet, right? This is a mass. The earth have some sort of mass, and the word, and from another mass, another mass, there's not earth, there's another planet, let's say P1. Okay, so there is a earth and planet P1. There is a huge gravitational field in this space, and right what I'm saying, there's a gravitational field in this space. We assume, that physicists assume, there is some sort of field which are interacting between these two masses, which brings a force, and that's how the force exists. That's how a force come to be existence. So this is what it's talking about, and there is a field, and this field equation is found to be this one. So it's actually, what is field? If you define the gravitational field, we can say that it is a force experienced by a mass. It is what is force experienced by a mass. So gravitational field is nothing but it is a force experienced by a mass. And we just discussed that force is G m1 m2 of two planets upon upon r square, right? There is already m over here, and one m gets cut, and then we get G m upon r square. So this is simply derivation. This is simple derivation. We just derive this formula. Okay, so this is what is about gravitational field intensity. So let's summarize everything very quickly. We just discovered gravitational force formula, which came out to be our just gravitational formula came out to be force equals to G m1 m2 upon r square, which where you have to know the terminologies. Okay, where is the force between two bodies? Is gravitational, universal gravitational constant. This is a mass of one body. This is a mass of another body, and this is a distance between the two bodies. And also we derived the gravitational field is G m upon r square. So it is a field of planet having mass m1, or simply says having mass m. So this is come, and what is weight? Weight is actually gravitational field is actually, also we get the force equals to mg. We have in lower classes we already studied that force is equal to mg. Do you know how this force came into existence? This is if we look into very depth of this concept, we find that there is a force due to gravity. Look at this equation pretty quickly. Let's look the equation very quickly. Okay, so this says this is a force equals to mass into gravitational field intensity, which simply means if there is a planet of having mass m, and there is a field of this planet, right? I'm assuming, okay, so there's no such thing as this like sun I have drawn. There's no such thing as these are not real. Okay, so I'm just assuming So this m is, it has its own field. Okay, let's say this is a field, and if I just put another body of here, okay, now this body experience a pull force by this planet. So what's the magnitude of this force? Is actually its own mass, its own mass into the gravitational field of this planet having mass. So it's gravitational field of this planet. So this is what is came out to be mg. So this is very logical, but we don't have to go in very details. Just for competitive exams, we just have to know this formula is F is equal to mg. But actually, when you get into depth, we just found out this due to this gravitational field, there is a mass m. If there is a mass m in this gravitational field, then it's experience a force. So it simply says that if there is something mass in gravitational field, then it must experience a force. So this is what it's talking about. But we even we go in depth, we just, this is just a modification of this formula. If you just solve it, okay, so if you just solve it, m, and if we come, g, what we called it, g m, I'm denoting the mass of planet is capital M, and this mass, this mass is small m upon, what is g, upon r square, so this is simply g m upon r square. So this is what is the beauty of physics. Okay, no matter what is the formula, is a tool. The mathematics is the tool to describe physics. So the logics is always logics, equations are always valid, no matter what is equations speak in physics. Okay, so this is the beauty about physics. So in conclusion, we discovered three formulas, that is F is equal to gm 1 m2 upon r square, g equals to gm upon r square, and F equals to, what is F equals to mg, which gives weight. This force is actually this is what we call weight. Weight, this is what we call weight. So these are the things to be remembered. And now let's go to solve some MCQs. Okay, so this is, now let's solve some MCQs. I have brought some MCQs related to this topic. Let's solve it. So first question. Now first question says, okay, so first question, if the moon is brought closer to the earth such that its distance from the earth becomes half of the original distance, then the gravitational force of attraction between the earth and the moon would be. So now let's talk about, so it simply says, what is it asking? It's asking gravitational force of attraction. So we already knew what is gravitational force of attraction. Gravitational force attraction. So we already know what is gravitational force attraction. Is gravitational force of attraction is given by F equals to g m1 m2 upon r square. So here says the distance from earth becomes half of the original. Matlab means r equals to r by 2. So we just keep it over here. R is kept as f dash becomes g m1 m2. Other are constant. This is constant. The planet's mass has not been changed. So r by 2 becomes, what is becomes is r by 2 whole square. So f dash equals to g m1 m2 upon, this is becomes 4r square. So 4 is in numerator side, right? So the f, this not, so f becomes 4 times, this is original f. See, this is original f. This is original f, so it becomes 4 times. F dash equals to 4 times. It becomes 4 times of the original value. We don't need to, it's just simple logic, we just know the formula, right? F equals to g m1 m2 upon r square. We know that the force is inversely proportional to the distance between them, which simply means if we just half this will go to the upside and becomes 4 times. So this is what is the correct answer. So now let's talk about the second question, 87. Okay, so the acceleration due to gravity at the earth's surface depends upon, we already discovered the formula. What is the formula of acceleration due to gravity? Simply g equals to g m upon r square. So this means what is depend upon? It's mass only, radius only, both mass, and so it is simply mass and radius, both things. If the distance between two objects is increased by 2 times, then gravitational force between them. So it's simply the same things. Force is inversely proportional to r square. So if the distance between two objects is increased by 2 times, so if we increase this r 2 times, gravitation force becomes 4 times. So it will say 4 times. Why? This is inverse square rule. Okay, what happens to the gravitational force between two objects if the mass of one object is doubled and the distance between them is also doubled? Same concept again. If the force is directly proportional to m1 m2 upon r square, so if we one object of mass is doubled, so we doubled one mass and the distance between them is also doubled, so distance becomes 4 r square, so 2 to the 4, so force becomes f by 2, so force would be halved. Let's go to the next question. An object's weight 9 Newton on the surface of the earth, what would be its weight when measured on the surface of the planet where the acceleration due to gravity is 9 times that on the earth's surface? So we already knew, right? We already discussed. Look at here. Okay, so look at here. Look at here. Look, this is what I am talking about. So F equals to mg gives weight of an object. So now let's talk about the weight of an object. The question simply asked, the object weighs 9 Newton on the surface of the planet, so weight equals to mg. So that is, weight is what is gravitational field proportionality. So weight 1 upon weight 2 gives g1 upon g2. So initial weight, let's say w1 equals to initial weight, which is 9 Newton, and let's say w2 becomes w dash, which is the final weight, and g1, what is g1? G1, let's say so g1 is the gravitational field of the earth and g2 be the gravitational field of that planet. So g 9, right? 9 times g, so it is gravitational field 9 times, so g get cancelled and weight comes out to be 81, which is what? Initial, so which is also 9 times, right? So previously there was 9 and now it becomes 81, which is what is, which is initially 9, now it becomes 81, which is 9 times. So very easy. Okay, so this is a good question. In respect of the gravitational field, in respect of the difference of the gravitational field from electric and magnetic force, which one of the following statement? It basically, we have to know the difference between these forces. Okay, gravitational force is stronger than the two. No, I already said it is a weak force, so it is never a strong force. Look at here, I have mentioned here, see, it is a very weak force but very dominant force, so it can't be stronger than forces like nuclear force or electrostatic force. So this is a very wrong options, and gravitational force is attractive only, whereas the electric and force, so this is what is I already mentioned, gravitational force is always attractive in nature. And let's go to other options. You see, gravitational force has a very short range. No, not very short range, it's a very long range. It acts between the heavenly bodies and the planets in the solar systems, like planets, suns, stars. So this is what is actually, sun and stars are the same thing, so but we said let's say star. Okay, so it acts on the very long range. Okay, gravitational force is a long range force while the other two are short range force. In respect of the gravitational force is attractive only, whereas the electric and the magnetic forces are attractive. Gravitational force is a long range force while the other two are short range forces. I mean, this statement is also not true but also not 100% wrong. Okay, so this seems to be very much middleman. So the best options is here is obviously B is the best option. Okay, so a brick is thrown vertically from an aircraft flying 2 kilometers above Earth. The brick will fall with a constant speed, constant velocity, constant acceleration, constant speed for some times, then constant speed as it nears the Earth. So it is basically a stupid option. So let's talk about this thing. A brick is thrown from a vertical aircraft. So let's say there is an aircraft and the brick is thrown over here, and a brick is, let's draw some pilots and let's draw some wings of plane. Okay, now it's actually perfect, right? So a brick is thrown vertically from an aircraft flying 2 kilometers above the Earth. Let's say this is 2 kilometers. Oh, the brick will fall. Now, how does the brick will fall? With constant acceleration, with a G. Right? So this seems to be correct option, with constant acceleration. The brick, there is a one, when it enters into the gravitational field of Earth, when there is, let's say this is a brick, let's make of here Earth. So this is the Earth of having mass m, when the brick enters into the Earth's magnetic field, Earth gravitational field, then it experiences a force, and this force is equals to mg, where this m is the mass of this brick, and So this is what is constant acceleration. G is value for G is fixed, you know. Now let's also discuss this. We talked about G, you know. What is G? This G. This G. This is also fixed. We can find the calculate the value of, see, this is also constant. Okay, so this is fixed. This value is 6.67 into 10 to the power minus 11, and the mass of earth is also fixed. I don't know the exact value of the mass of earth, but it is also fixed. Radius of earth is something 64,000 kilometers, 6400 kilometer squares, and when you put the value we can get 9.8 or something like this, very near to approximately this is. So this is a fixed value of which we call acceleration due to gravity. So this is also fixed. Now